Hello and welcome to G Fun Facts Online. Today, we're looking up, way up. What if I told you there are rivers flowing thousands of feet above your head? Not made of water, but water vapor. Colossal, invisible rivers that silently shape our weather, our water supply, and our world. They're called atmospheric rivers, and they are one of the most powerful and fascinating phenomena on our planet. So what exactly is an atmospheric river? Picture a massive conveyor belt in the sky, thousands of kilometers long but only a few hundred wide, hauling incredible amounts of moisture from the warm tropics towards the poles. To give you a sense of scale, an average atmospheric river carries as much water vapor as the entire Mississippi River flowing into the Gulf of Mexico. The really strong ones? They can carry up to 15 times that amount. At any given moment, there are about 4 or 5 of these massive rivers actively flowing somewhere around the globe, playing a huge role in the global water cycle. In fact, they're responsible for transporting a staggering 90% of all the moisture that moves from the tropics to the poles. The birth of an atmospheric river is a complex atmospheric dance. It all starts over warm tropical oceans. The high heat causes massive amounts of water to evaporate, lifting water vapor high into the air. This moisture-rich air is then caught and steered by powerful, high-altitude winds we know as jet streams. Often, these rivers form ahead of a cold front. As the cold front advances, it acts like a giant squeegee, sweeping up and concentrating the water vapor from the warmer air into a narrow, supersaturated band. When this long filament of moisture finally makes landfall and hits a barrier, like a mountain range, it's forced upwards. This upward push, called orographic lift, cools the air, causing all that water vapor to condense and fall as immense amounts of rain or snow. And that brings us to the dual nature of these sky rivers. They are a classic double-edged sword. On one hand, they are a vital gift of water. In the western United States, for example, atmospheric rivers can provide up to half of the region's entire annual precipitation. They are crucial for building up the snowpack in mountain ranges like the Sierra Nevada, which acts as a natural reservoir, storing water that feeds rivers and reservoirs in the dry, warmer months. It's estimated they've been responsible for ending about 3/4 of all droughts in the Pacific Northwest between 1950 and 2010. But there's a dark side. The same systems that bring life-giving rain can also unleash utter devastation. When an atmospheric river is especially strong, or if it stalls over one area for too long, the sheer volume of precipitation is overwhelming. This leads to catastrophic floods, dangerous landslides, and massive damage to our homes and infrastructure. In 2019, a series of these events in the western U.S. caused about $1.1 billion in damages. You might have heard of the Pineapple Express. That's a famous, powerful type of atmospheric river that funnels moisture from near Hawaii all the way to the U.S. West Coast, often leading to incredibly intense storms. So what happens when you add climate change to the mix? Well, the science is clear. It's making things more intense. A warmer atmosphere can hold more moisture. It's simple physics. This means atmospheric rivers are becoming bigger, wetter, and more frequent. And that, of course, increases the risk of more extreme rainfall events and more destructive floods. Scientists are also seeing a poleward shift in their tracks. This could mean more intense rain for higher latitude places like the Pacific Northwest and Europe, while the subtropical areas that depend on them could face longer and more severe droughts. The relationship with other climate patterns is also getting more complicated. We usually associate La Niña with drier conditions in the American Southwest. But in 2023, a La Niña year, California was hit with an unusually wet season thanks to a parade of powerful atmospheric rivers, completely overriding the expected pattern. Given their immense power for both good and ill, being able to accurately forecast atmospheric rivers is a top priority for scientists. Using a combination of satellites, radar, and advanced computer models, researchers are getting better at predicting these events, sometimes giving us a 5 to 7 day heads up. This advanced warning is absolutely critical for water managers trying to fill reservoirs and for emergency services preparing for potential disasters. As our climate continues to change, understanding, predicting, and adapting to these incredible rivers in the sky will be more important than ever. So next time you're in a heavy downpour, especially on the West Coast, take a moment to look up. You might just be standing under one of Earth's mightiest and most important, invisible rivers. Thanks for tuning in to G Fun Facts Online. We'll see you next time.